Hello, welcome to my bench. Today we have something I got in for repair. It's an Icom IC-PS30 system power supply. This thing is in beautiful shape, and it's goes along with the IC-741, I believe it is, and it's the power supply that drives it. Power cord here, and there's the plug. It goes back in the back of the radio. So it's kind of all contained, and their wires are attached. On the front of it, we got a power light, an on-off switch, a amp and voltmeter, and a switch for current, I/O, and voltage out. Current out, voltage out. That's pretty much it. On the back, what do we have here? Well, we got, this is your AC in, a fuse, a ground, very necessary. This is your 13.8 volts output. Put you over to the side so you don't end up on the floor. And you've got 3 extra 12 volt outputs here, I believe. For other stuff, well, we'll look on the schematic when we see it. The guy says this one doesn't work. So, first things absolutely first. Whoops, sorry about that. There we go. Let's take a look at the fuse. And the fuse is good. So on 110 volts, 117 volts, it says it should be a 10 amp fuse. And it is indeed a 10 amp fuse. So we'll put that back in. Alright, let's see what we can do with this thing. I took the screws out just because you don't need to see me taking screws out, but there it is. Nice. What do we got here? Well, we got a plug unplugged. This plug goes back in. And there we go. Alright, that's just the power out to it. Got a little fan, little shaded pole fan. Let's see, the input comes in, goes through this little choke coil. I don't know where else it goes exactly from there. Through the fuse. And up to the switch and back again. Okay. So, here's our inputs. Another nice little choke coil. Here's your, we set it up for 110 or 230 volts. Very clearly marked. And it is set up indeed for 110 volts. This is your bridge rectifier with a little heat sink on it. Capacitor. No. Relay. That's a relay. I don't know what that is exactly. R5. Nice big filter caps. This is a BA4558. We'll look that up in a bit. And Q1. And that's about all that's on here. I suppose the rest of it's inside this thing. There's a 5 watt 1K resistor on the side of it. And a terminal block here. That seems to come off, some of it comes off to the meter switch. And 2 big old giant red and black connectors which I'm sure go to your power out. So, all right, well, let's take a look at the manual first, and just to see what's going on. All right, let's make the manual a little. Why is everything falling apart on me here today? Get that out of the way. All right. There we go. All right. So what do we got? Let's get rid of the meter for now. All right. So here's our power in. And let's see. There's our power in. There's our coil. There's the fuse, the coil. There's the switch. And a cap going to ground. And then it goes... It has taps going over to a relay right there. And P1 meter. Well, what is that? Okay. Well, first things first. Here's where you switch it between 110 and 230 volts. The 110 we're interested in goes over to here, to one side of your diode, or one side of your capacitors, and the other side goes to here. So, all right, it just goes to the bridge rectifier, and those 4 caps, and then out. So there really isn't much there. But what we got is this. That's R5. Yeah. That's our R5, and that's 3 ohms, and that is across that relay, RY1, which is RL1, which is right here. Okay. Well, I guess first thing we'll do is take some voltage measurements. We'll shrink you down, put you up here so you can see what I'm doing. All right. Put you back on volts. Bring the meter back up. And we will bring this thing up slowly on the light bulb and see what it does. All right, so it's on. And we'll put you down here for now. All right, it's on. We're going to bring it up. Switch is on. Watch the current. You can't see this. Okay. There's 98 volts. Absolutely 0 current. Really? Okay, there's 120 volts. Absolutely no current. The light is not lit. And I'm drawing, it says 5 watts. There's no lights in the front, no nothing. Well, let's see. AC voltage. That would be AC1, AC2. So we got 121.3 volts of AC. And that little fan is trying to turn. That's interesting. All right. Well, what's going on here? Okay. Let's see, where is... This corner is negative, that corner is positive. So let's put this thing on DC. Turn it on again. Don't hear any relays. There's negative. There's positive. I got nothing. Nothing coming out of the bridge rectifier at all. Okay, with that 3 ohm resistor right there, with that 3 ohm resistor, I should have voltage on this thing. Yes, because that goes right over to that side. All right, so I got no voltage at all. Well, let's test this. Well, I got no voltage in there. Let's see. This resistor, how can I test this resistor? That resistor goes right straight to one side of the line. All right. Here's that resistor. And we'll measure across the resistor. We got 1.75 mega ohms. 1.5 mega ohms. Wow. Okay. That's a 3 ohm resistor. Let us take that out. Ow, ow, hot, ow. I don't know why I reached for the solder wick. Probably should have done that with a sucker. But it is what it is. All right. Got a little piece of stuff on it. Okay. And it's open. So this 3 ohm, looks like about a 2 or 3 watt resistor is open. Well, that makes me think, what the heck would open that resistor? The only thing that would open that resistor, let's look at the manual again. Alright, so if those capacitors are shorted, it'd do it, but I seriously doubt that. So that would just be this output, and it comes out to here, and it goes right straight down to these transistors, I believe, and all that stuff, I believe, is down underneath here. Let's put a screw or two back into this thing. So it don't flop around in the breeze and break something. There we go. 2 ought to be plenty. I'll bet you. Come on. I'll bet you if I go to here to ground, bet if I go across those two, I got a dead short. Whoops. Yes, I do. Come on, behave. It's really hard to get in here with these probes. Okay. Come on. Yeah. So, how do I get this out of here? There's 1, 2, 3, 4, 5, 6 screws under here. And they are number ones. Interesting, though. These screws that box is isolated. Huh. Okay, look. Look at that. It's isolated from the case. I don't think I've ever seen that before. Okay, well, let's get the rest of them out of here. Damn, they're long-winded, too. Yeah, him got a hold of me off of here. Said, hey, I got a 741. Can you work on that? Well, why not? I mean, you know, radio's a radio. So he sent it to me. Said this was busted. Okay. Well, I'm going to have to get this off the side, this 1K 5-watter, because it wired up too tight. Okay, well, let's see. Oh, Lord. Wow. Well, I guess that's for RF proofing. One. Missed. All right. Where you go? Right there. Okay. So. Ta-da! Oh, there it is. Okay, so everything's inside this box here. All right, so what do we got? We got a big old honking cap. Big old honking wires. Transformer. All right. So, if we take a look at the manual, what we got? Here we go, come in here through L1, which I believe, yeah, L1 is there. So there's our input. L1, couple of caps, C4 and C5, they look okay. Comes right straight down to the 2SC 2307s and 2SC 2501s for power. And we got a UPC 1042 for the switch mode. Well, So that means that couple of rectifier diodes up here. Yeah. So basically, there's our output, and it comes down to here and right to our output of 38. Yeah, all those three in the back are supplementary 13.8 volts. So it's right here. And where's the ground? Ground is over here. Okay, that's the meter driver. Okay, well, there ain't much there. We got your controller, your transformer, which I believe is going to be this big one over here. And I think, let's see, T2. That's T1. That's T2. All right. So here's your transistors. Here's T2. And here is probably T1. Or L2. So that's your coil. All right. Well, it's beginning to look like we got shorted transistors. We're still on ohms. Take the meter here, go to negative output, which is right there, and test here. No, okay, good. So let's go here to here. Huh. Yep, that's called a short. That's called a short. That's a short. That's definitely a short. How about the 2501s? Those are the 2307s. Yep. 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 Well, we got one that's not a short? No, it's a short too. So, all of those are three-legged conductors. And this is your diode up here. Hopefully it's not short. Well, I can't tell because it's going across that. Wow. Okay. Well, couple of 2307s at least to start off with, and a couple 2501s. Gotta order that. Okay, hello, welcome back. We got parts. Got a couple of 2SC2307s, a couple of 2SC2501s, and I couldn't find exactly the right resistor, but I did get this. It's a 3 ohm 5 watt we're going to put in there instead of this thing that came out of it. Still 3 ohms. I guess. Get to it. Only took a few days to get the parts here. I ordered them. I try to order from in the States if I can. So these only took like, less than a week. Much less than a week. Let's get these guys off of here. Well, let's see. These are plastic screws on the 2501. And these things are just mounted to a to wires coming up out of the board. Well, that's nice. So I don't even have to take the board out. Of course, this all sort of depends if this thing works. If that 1042 works. Let's put this guy on the little meter here and see what it says. I think it's going to say it is 2 resistors of rather low value. I'm willing to bet on it, as a matter of fact. Could do it on the meter, but you know. Alright, what we got? It says self-test mode. Okay. That means that all 3 legs are shorted to each other when this thing goes short self-test mode. So, yeah. That is a dead one. Oh, this one's kind of crooked. Ooh. Somebody... I got to be careful because I don't think I've got any of those plastic screws. Somebody put this in crooked from the factory, I believe. Where you go? Where did you go? There it is. Yeah, we're going to have to be careful with that. Sue. Oops, I hit you. Sorry about that. All right. Well, that last one was definitely 3 pieces of wire. All connected together, because that's how you calibrate this thing, is you hook all the wires together, the 3 leads. Okay, so there's that one. And just for fun and grins, let's take this. That is short. That's shorted. Cool. Alright. At least this one's got a real screw in it. And it's kind of stuck to its backing here, too. Alright. Wow. Stuck to the sill pad. Alright. Purpose-made sill pad. Alright, let's see what this says about this guy. No heat, no grease on this at all. That's kind of interesting. Just a sill pad. Well, I guess if they're made right, you don't need grease. And hit it. And what does it say? It says we got a 0.16 ohm resistor between 1 and 2. Yeah. So, yeah, no. I was right so far. Question is, what took this thing out? Hooking it up backwards, maybe? I don't know. Wow. Ooh, pop. Oh, this one's different. This one's got the sill pad on a heat sink. Interesting. So these two have a ground? That's interesting. Goes down to the board there, but it's not connected to anything. It's just a ground. Does the schematic show that at all? And no. So, what does this one say? I bet you it's real close to the same thing. And we have a 0.14 ohm resistor between pins 1 and 2. Okay, well, and this has a little rubber standy off on it, a little rubber gripper to keep it, I guess, away from that. All right, well, we'll just set that over to the side. All right, well, just because I don't like surprises, I'm going to test these 2307s, make sure they're okay. This one says it is a NPN with an HFE of 9. Yeah. These big old transistors, the current gain is pretty low on a meter like this. It'll be between 9 and 20. Yeah, this is 12, 0.554 forward. Okay, and the 2501, just because. Yeah, it's an NPN, HFE of 26 and 0.648 volts. Again, it's pretty low on HFE, but that's normal. And 24 with 0.652, good. And they are BCE. Okay, well, let's get them back in here. Make sure these guys are not contaminated. It's not. All right. Let's just put that in lightly for now. And the little guy here, oh, a little too hard. Got to get the sill pad lined up. There we go. And the screw. See if I can get this back in here right. There we go. That went in better. Alright, now we gotta form the legs here a little bit. These were basically just bent. So that they all met the pads down here. Little things sticking out of the board. Okay. And you are where you're supposed to be. Alright. Now we're going to take the ohmmeter and we're going to test this to here. Oh, nothing. This to here. Nothing. Good. Alright. Next. Interesting that they all just sort of went. Of course, they are hooked up all together, so I guess it's not that unusual. Plastic screw, good one. Crud. This thing's at kind of an angle, so it's relatively difficult to get it exactly where it needs to be. Hold on to the screw and the screwdriver and everything else all at the same time. Yeah. Feel it, feel it. Yep, there it is. Okay. All right. All right. Test for ohmages. That one's good. That one was a cap, and that's good. All right. Now we got to solder them back in here. First thing you got to do those. I will leave those leads just like they are. Cut these off. So that they don't bash into anything down here. Hopefully, this fixes it. That would be nice. Kind of got my doubts because something took it out to begin with. Interesting way of mounting these things, I'll tell you that. Alright. Because they were just blob soldered onto the side of these posts sticking up out of the board. Just like this. I'm not doing anything different than they did at the factory. Yeah. I mean, it's nice that it made it fairly easy to get to them, but seems just a little bit hokey. But who am I to argue with Icom, right? And this one's off-centered just a little bit, more than the other one is. Come on, get out of there. All right. This one, good. 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 I think let's take a look at them with the old flashlight here. And the gate glasses. Yep. That one could stand to be a little more. It's connected, but I don't like the way it looks. Yep, and yep. All right, well, there's that. Take your little thingy here, stick him back on there so that thing can't go any farther than it does. I mean, that must be why it was there. Spin you around, put you back inside. All right. Sorry about that. Okay. Hard for me to tell where my head is when I got on my gate glasses. Okay, we got to take this off. And put that big old honking resistor in there. Okay. Let's put it so as you can read it. I know the resistor's too big, but it was what I could get. All right, let's chop these off. And while I'm at it, I mean, they didn't bother to, but let's get some of this schmaltz off of here. I mean, Icom didn't bother. Just make it look prettier for the next guy that yeah, that's better. Not much, but a little. All right, well, It'll dry it off a little bit. It does have some sort of a coating on it. It doesn't come off with isopropyl alcohol, but it does take off the extra flux. Alright, let's screw this thing down, a couple of screws, and give it a test and see, without having it hooked up to the rest of the box, if we now at least have voltage coming out of the, here, heck, voltage coming out of there. If we got voltage getting to there. So if I turn this on and it works at all, at least the fan should probably spin, I think. I got it all disconnected. There. That's in there, right? Alright, let's take the voltage down on you. Turn you up. You're on. Current. No current. Up to 102 volts. And no current draw. Nope, not drawing any current. There's 120 volts. Let's see if we got any voltages coming out of this thing at all. We'll just go for broke here and go right to the B+. Yeah, if I can get to it. We'll just do it this way. We got 32. What? 327 volts. Well, you know, all it is a diode and some capacitors. Hey, let's go for broke. Let's plug her in. Bring her up slowly. Current limited. We're getting a little bit of current, but not much. The light bulb is not on. We are in bypass. We have no power indicator, and the fan is still spinning very slowly. What do we have? Back here for voltage. We got nothing. Okay. Well, there's test 1, and that didn't work. Let's oh, click, the lights just came on. It did not like coming up slowly. What do we got here? 14.6 volts. Really? Well, this says 14 volts right on the meter. Son of a gun. Well, That's interesting. So, okay, it's off protect. We're still at 13.6, 14 volts, and no current. I'll tell you what. It takes it a long time to die. There it goes. All right, well, let's try putting a little current on the thing. How would be the best way to do that? It'd be that guy and that guy. All right. So let's power up the old. Actually the new one of these, and that would be you and you, and see if we can draw any current off this guy. We may have fixed this. Okay, so it says 14.6. There's a couple of amps, it's 14.0. There's 4 amps, it's 13.6, and it just shut down. Where is it shut down? There's 3, there's 4 amps, there's 5 amps, 6 amps, 7 amps, 8 amps, still holding 13.4, 9, there's 10. That's what the meter says also. 10 amps, it went off. Okay, so I got this thing all torn back apart again. And got to figure out what's wrong with it, because I can't. It got worse and worse, and eventually I couldn't draw any current off of it at all. I got this load here that I use. It's just a big old 8 ohm rheostat that I can adjust down to, about half an ohm. I also use it for doing audio. Put amplifiers into it's 300 watts, so it gets warm, but it won't burn up. Anyway, I want to start doing some static tests and see what we can come up with here, because something is wrong. Let's see. If we take a look at the manual here again, according to this manual here, base emitter, so I got, should be about 22 ohms. Let's take this back. The ohms. And that would be what? R17 and R20. Here's R17. 22 ohms. That's good. Here's R20. If I could get on it. 22 ohms. That's good. All right. So then we got what? R16 and R19. I don't know where those are. Don't see them right off the bat. Well, they have to be working. I wouldn't get any drive at all. So, what else we got? Let's go down to the 2307s. So I should have base emitter on those, 4.7 ohms. So let's see, that would be what? R18. I got 94 ohms across R19. That should be 4.7. And R21, 44 ohms. Well, that isn't right. Alright, so I've clipped those two out of there. Let's get a couple of 4.7s. I suppose. When it took out the transistors, it could have weakened and or taken out these resistors. That's interesting. But they provide bias for the base, so that would make sense why it would not allow me to adjust it. I tried adjusting this pot down here, right there. I tried adjusting that, and it wouldn't make any difference. It still would not draw more than, I couldn't get more than an amp out of it, no matter what I did. So, there's 19. Okay. Let's test those two while we're at it. We're waiting for the soldering weapon to heat up. Let's see, from there to there. Well, let's see. Where else can I get those? Because they're too close to the board. Look at the manual again. R16. So one end goes to the base, which is there. The other end goes to there. Huh? So is this gone too? This should be... Wow. That's interesting. I can't... It's very hard to get on these. So are those gone too? Really? So the R16 is 4.7, and I just can't. And it says 73 ohms, 72.8. If I go the other way, just in case the meters. All right. Well, I can't do that. Guess I gotta take this apart. Okay, well, got this thing out of here. It's not really made to be worked on. You have to tear an awful lot apart to get this stuff out. But anyway, let's take this resistor out. We'll find out if it is indeed bad. 4.7 ohms. That's what it says it's supposed to be on it. Hard to get this thing down. I can't. 1K. Put the little grabbers on the ends of the here so I can get to these things easier. Alright, there's one side. There's the other side. Okay, so that 4.7 ohm resistor is 1 kilo ohm. Okay, let's tie this one. Not that I can actually get to it very easily. So when those things went, it took all these resistors out with it. Alright, here's the other one. This is R19. And it appears to be 54 mega ohms. Just to show you, here is my new resistor. 4.8. Alright, so I need 4 of those. And it looks like, if I'm not sadly mistaken, one of those capacitors there. That's a C12 and C13. .2s. Okay. Well, I guess maybe we better check those too, because this one's cracked. Wonder if it's possible that it blew it up. Function ohms, nanofarads. This thing's slower than come on. No, it's not going to read it. I'll have to use the little machine over here. The capacitor function on the on that meter up there is pretty much worthless. For one thing, it's so slow. And it doesn't work half the time. So let's see what this little guy says. It's a 63 ohms resistor. Wow. It says 63 ohms and 36.5 henries. Well, I have one. Let's see what this says. This says, I don't know. And it says 189. Yeah, 189 nanofarads. So that one's 0.2, and that's, well, it's 180. Wait a minute. Here is a 0.22. I have 0.22s, but they're not very large. 220 nanofarads. Okay. Well, that isn't a big deal. And let's check this one, because it is cracked also. Come on. I have a feeling this one's going to be just as bad. And it says, question mark. What is this one? Is 23.1 ohms. Really? So let's put it on this meter. This meter, take it back to ohms. See what it reads it as. It reads it as 23 ohms. Okay, well, so I need both 0.22s, and I need 4.7s. Okay. Well, let's clear these holes out a little bit. Should be able to do it with this thing pretty easily. You can't get this board any farther out because everything's tied into it. You have to work on it like this. Pain. Let's try this one here. Really? Just come out of the hole. I do have to get this off of here, though. Big old blob of solder here. There. Well, I'm going to change my pad after this on this solder sucker. Although, I'm trying something on the solder sucker here that I saw somebody else do. They put a little bit of that copper wool that you use to wipe your that you use to wipe your soldering iron off on in here instead of the pad, or the little, there's a little felt pad that goes in the back here. I'm seeing how that works. The jury's out. I don't know yet. Alright, so holes empty, 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 and empty. Alright, so they're all good. Alright. 0.22. Oh, this one's not. Forgot one. Now it is. Alright, so we got 0.22 goes here. Yeah. Would help if you actually got it in the pad. Pads all came loose. Alright. 4.7 ohm resistor goes there. Another 4.7 ohm resistor goes here. It says body here, so we'll put body here. Okay. We're going to use this greenie. It's 190, and I'm sure it's close enough. Now we got to get a couple more resistors. Yeah. $4.7. Yep. Well, it's not. At least this is fixing something that was actually broken. I do a lot of these things called Symmetrics 528Es, and they're just all bad caps all over the place, including the surface mount ones. Alright. That's grunt work. But they're good mic processors, and they're still used in a lot of places. Come on, thank you. I don't know what the solder is they used on here, but it likes to splash, which is weird. It like strings on you. More than normal stuff. Alright. Let's take a look at that and see if we shorted anything out. I don't think so. They're all pretty much pushed together anyway. And let's scrub the board off a little bit. Like I said before, this board's got some sort of a coating on it that just colors. Okay. Alright, well, there's all of those. You see me do that. Now I got to put this whole thing back together again. And I got to put it together before I can even test it. That's fun. Cleaning up these pins a little bit. Okay. Alright. I'll put this thing back together. Okay, well, we got it all back together. I've got it plugged into the dim bulb tester, but I can't actually use the dim bulb tester because it draws so much current on startup it won't start up. So what we're going to do, I'm going to test it. I've got the dim bulb tester in bypass, so I'm going to test it on my little electronic load here, just to see it. The resistor works okay, but it's hard to change it because you go from 0.55 ohms to 1.38 ohms on an 8 ohm resistor. So I'm just going to use this. Now, this thing in the instruction says it's good for 25 amps at 50% duty cycle for 10 seconds with 10-second release, I believe. Something like that. But so we're not going to test it at a full 25. We'll see if we can get it up to 15 and see if all that we did fixed it. Now, what have we done? We replaced all 4 transistors, the 2307s and the 2501s. We replaced 4 4.7 ohm resistors and 2.2 capacitors. We replaced the 3 ohm resistor up here that acts kind of like a fuse, and I recapped the entire animal. So it's everything. All the caps have been changed, and now we're going to see if indeed this thing will work. Now, one thing you got to make sure if you work on these, make sure that this box is not shorted to the chassis. There is a plastic sheet underneath here that isolates it from the chassis, and we're going to test that real quickly just to make sure. Put this guy on ohms. I gotta pick up some more leads. I'm getting sick of swapping the probes all the time. There. Alright, we're gonna put this guy back here, and we're going to test here. Overload, whatever that means. This meter has some very strange little idiosyncrasies, but it is not shorted. That's what we wanted to see, because if you short this out, you will blow the thing up. You'll take out the fuse, you'll take out the transistors, you'll take out everything. Alright, so cross your fingers. Here we go. That fan back there is still iffy. Got to tear that all apart. Alright, we got 15.1 volts. Ooh. Alright, well, we'll have to adjust that down some. And we'll give it some current here. We'll see what happens. Dropped it down to 14.5, and that's 2 amps. The meter is reading about 1.5. There it's reading 3, so we have to adjust that. Wrong one. Actually, turn it off, turn it on, get my meter zeroed here. That's 0, okay. Alright, let's see what it does here. There's 7.5. There's 12 amps. There's 15, and I don't want to leave it on longer than that. Alright, so now we got to figure out, we got to adjust the current. That's underneath. Hold on. Okay, so we got it. I went back underneath it and adjusted the voltage so that it was where it's supposed to be, and now we've got 13.8 volts, I believe. Yeah, well, 14.3. We've got a 14.3 volts down here, and when I give it some current, I don't know, let's take it up to like 5 amps. It's holding 13.5, 13.4. 8 amps is 13.4. 11 amps is 13.2. There's 16 amps and it's 13.0. So that's within the regulation capabilities of this machine. Anyway, well, we finally got it. That was an uphill battle. That was a lot of problems. I still don't know what took it out, but oh well. I mean, that's neither here nor there. Anyway, hey, there you go. A Icom IC-PS30 power supply repair with a whole lot of stuff bad in it, you know, but it is what it is. Hey, thanks for visiting, and don't forget to sign up down there and ring the bell so that you know if I'm doing more of this stuff, and say thanks for coming.